that shipping, as you know, John, shipping the batteries is not only difficult, it's also a safety issue in the sense that there are some sensing wires on the top that are not fuse protected. They're 22 gauge, so I think if they even shorted, it wouldn't be catastrophic. But nonetheless, I have some concerns about shipping certain batteries. I've tried to do, a few different things like electrical potting compounds and whatnot. But I really think building a box with everything confined is the way to go.
So Ryan, can I stop you for one moment? Because
absolutely,
let me start the regular agenda. I had a couple of things I wanted to talk about that was kind of REOCA business. I'm going to share this. Give me a second to find my mouse.
And yeah, when you're ready, Ken, for the presentation, I'll go ahead and introduce Ryan.
Okay, yeah, thank you. Is that showing my agenda?
Yeah.
Yes.
Okay. So the link in our email is not working, and I'm trying to get it so we may have members join us. But I'm recording this meeting, and if nothing else, we'll package it up as a video. So so welcome everybody, to our member meeting. We'll introduce Ryan later. I wanted to talk about a couple of things that REOCA is working on. We got a grant to work on a legislative action, and I just wanted to talk about a couple of things here. So we have a legislative committee, and we're collectively working with other organizations, but so we're kind of tracking the legislation in Colorado to do with energy, mostly renewable energy. And there's a couple things. There's a couple things. We're promoting SB 21-200, which is the reduced greenhouse gas bill. I'm going to go back to the membership thing because that I just wanted to show that tracker to let everybody know that we're actively working on this. We have a legislative committee, but this SB 21 is a bill to kind of meet the existing law in Colorado goal to reduce greenhouse gases, and it has some milestones in it. Certain years where the greenhouse gas reduction needs to be reduced from 2005 standard. And by 2050, we're supposed to be at a 90% reduction. So we're doing a lot of legislative action, Facebook media ads to promote that bill. It's right now in the Colorado Senate. There's a lot of controversy about it because it requires us to measure to make it equitable and enforceable. So that's one bill. One that's really interesting is a bill SB 21-261 that's very good for renewable energy. And right now in Colorado, if you install a rooftop solar system, the maximum you can build it to is 120% of your use.
Say that again.
So if you put a rooftop solar system on your house, by Colorado state law, in Colorado, of course, that the system can be built to 120% of your normal use. So you'd be violating the law if you built a bigger system. Okay.
Yeah.
This new bill will take that cap away. Now it may be amended. It may not make it through the legislation, but the idea is to take that cap away because people are going to want to buy EVs, for example. It also has some language in there about multi-tenant buildings, so it makes it easier for a landlord to pass that reduction in cost to his tenants. So it's really a pro rooftop solar bill. So I wanted to bring that to people's attention. If you see things about 621 or 261, excuse me, 261, you may want to send your state rep or state senate a message saying, hey, I support that bill.
There is the only problem. I guess the big issue would be the same reason you get penalized for consuming. I mean, you have to size the lines, and you have to size a lot from the utility standpoint. Being able to generate, upwards of 3 times the amount of electricity you would normally consume, is that they have to size their equipment for that. So they might wanna. There's probably, I could see some pushback in that sense. That's one aspect of where the battery backup could help. For instance, if they're only allowing a house to generate 2 kilowatts, but you have a 3 kilowatt array, that would allow you to feed 2 kilowatts to the grid and 1 kilowatt into your battery bank or your EV, for instance. But I know in some aspects, they penalize you for consuming over a certain amount also.
Yeah, it was. So I don't know what the law is in Utah. You probably should get familiar with it. Maybe you can educate us a little bit with that. A typical system in Pueblo is going to be around 6,000 watts, right? So 6 kilowatts.
Yeah.
So the utility companies here in Pueblo, which is Black Hills Energy or San Isabel, don't have any problems with that. And I think that probably is going to be a system that's typical in Colorado. The typical user in Colorado is 500 or 700 kilowatt hours a month. So anyway,
are there any talks of, because I'm in the process of making my house off grid, and I would like to strike some sort of deal with the utility saying I will sell them electricity only when they really need it, and I'd be willing to sell it right out of my battery banks from a surplus. I don't know if that's a topic at all either.
Well, yeah, I think what you're talking about is you become a net metering customer, but behind that meter you kind of control where that power goes, right?
Yeah.
In other words, it feeds from your PV solar into that battery, and then you can direct it. Typically the batteries are smart, and you can redirect where that energy goes.
Mm-hmm.
So we can chat more about that in your presentation, but that's interesting. Or we could always have an offline chat on this too.
Yeah, we could talk about this for days, I'm sure.
Yeah. So I'm going to move on to the next topic. Okay. One of the things that we went through a strategic plan with the REOCA board, and so what our mission is to promote and protect rooftop solar and other renewable energy sources, right? We have an independently owned utility in Pueblo that has not been too nice to the customers. The bottom line is our electricity is expensive in Pueblo, much more expensive than in other areas. Compared to Denver, our electricity costs about 50% more for a residential customer. There's 2 independently owned utilities in Colorado. Black Hills has probably about 100,000 customers, or 140, 150 total in all the business classes. where Excel or a public service company, who's the other big utility in Colorado, has over 1 million customers. So Black Hills is kind of small. The Excel or public service company typically is kind of the 100-pound, the 1,000-pound gorilla in the electric utilities. Then, of course, there's a bunch of smaller co-ops that serve rural areas in Colorado by far, and municipal utilities. So there's these 2 IOUs and about 40 other utilities in the Colorado system.
Yeah.
Okay. So one thing, we're trying to be a little more professional in our activities. And when we do a video, I wanted to show this little video clip. So that's kind of a lead into a video. I hope you heard that, were able to hear the music. I have a son who's a professional musician, lives in New Orleans. We stopped that.
You can send me a link to that. Any resources or any things you want to share, you can email me.
Yeah, I'll be happy to.
Yeah.
Anyway, I wanted to show that because we're going to use that as a lead into the videos, and there's another little 10-second segment that would be the trailer out, or the lead out part of a video.
And this is just to gain interest in off-grid or battery backup.
Okay. So let's go into the main part of this presentation. John, do you want to do the introduction?
Yeah, sure. Thanks. And welcome to those who were able to get on, and a small group, but then you'll be able to have more individual questions of Ryan. So Ryan didn't know this when I first contacted him, but I've been searching for someone like him for years. I've been reading about EVs for years. And one of the obvious questions that came to my mind is, great for the environment, but what about when the batteries have to be replaced? That's inevitable. And what do you do with those? And lithium ion, long half-life, you don't want them in landfills. And then I read something, this was years ago, and maybe it was a concept paper at the time, that said, well, maybe we can recycle these batteries for home storage, because in a car, they're basically unusable after they get to 60 to 70% capacity, because they just won't get the range that a car demands. But for static home storage, why not? Why not just plug them in and use them for home? So I thought that was a great idea, but I've been searching for years for someone who's actually doing it. And I've been coming up with articles about companies that have government grants to melt down the batteries and try to reclaim the chemicals, but that takes energy too. And then about a couple months ago, I was doing one of my searches again, and boom, I came across a Washington Post article, and it featured Ryan, a guy living the dream in the Arizona desert, ordering leaf batteries on eBay and putting them together for off-grid storage. And I thought that was a great idea. Contacted Ryan, actually had a chance to go out and see him in his little shop, his little trailer shop out in the desert, and it's a real thing. And so I thought it would be of interest. It's a twofer, right? It's a twofer win. We're keeping these batteries, or Ryan is, out of the landfill, and then being able to use them for static home storage. So Ryan Pohl is high desert off-grid storage. Most of his customers, and as you can Ken sent out the link earlier to his website, are people that are living, off grid, and RVs and whatever, and trying to avoid having to to use consumable energy. So, Ryan, tell us about what you're doing and how it works.
Yeah, so as John said, I started High Desert Off Grid about 4 years ago. I studied mechanical engineering and graduated from that from Western Michigan in 2014. And then I went to Daimler Trucks North America in Portland, Oregon, where I diagnosed semi trucks, mostly electrical systems, for 3 years. And from there, I moved more or less into a small RV and started experimenting with off-grid systems and so on and so forth. And it kind of just piled on, which led me to, I just always tried to find better systems for that kind of thing. And I stumbled across some lithium packs, some old ones, and then I refined that process into mostly leaf batteries. Supply chain has always been kind of an issue with that, especially out of leaf batteries. I was once getting them at $40 for their modules. There's 48 of them in a leaf pack. I was getting them for about $40 a module, and now they're about $120 a module. So I think there's a large DIY community out there that's probably already tackling this, but it's led me to kind of explore other lithium options. I've been getting into nickel, manganese, cobalt chemistry lately, otherwise NMC. I've been experimenting with all sorts of other lithium chemistries. So I've built about, I would say, over 100 Nissan packs out of Nissan Leafs. I chose Nissan Leafs because they actually use a more stable, one of the most safest chemistries. The NMC has a tendency to have thermal runaway if a cell gets punctured or so on. And so I kind of started there was a lot of traction, a lot of interest in these type of things, especially because I was doing it for $350 a kilowatt hour, and most lithium batteries are going for about $1,000 a kilowatt hour. So I was able to cut the costs a lot by using salvaged lithium, and then furthermore, also keep them out of the landfills, like John said. So to me, it was kind of a win-win. To me also, I think it's scalable to any amount too. I think I've been doing my largest system is 15 kilowatt hours. Most of them are around 3 to 6 kilowatt hours. So yeah, last year I went down to Quartzsite, Arizona, and I did a lot of RVs. I did about 15 RVs. And I met my friend, I met the journalist for the Washington Post down in Mexico, actually, on a climbing trip. And she decided to do a story on me, and then John found me. So it's been quite a road in the last months. And I built a mobile trailer because I do a lot of mobile installations. I'll go out to Colorado, go down to Arizona, and do work on a cabin here. I got a cabin coming up in Paradox next week. And I do some farms to irrigation as well. So it's definitely possible to start doing residential houses and homes, but right now I don't think it's totally economical if the grid is available. I think net metering might be the way to go. But I think there's a bigger point right now too that we're all missing. And I think one of the big things is that we need to size these batteries responsibly. I see a lot of systems that are way oversized. And I think that it's kind of, even though it's salvaged lithium, we could be maybe powering multiple homes instead of one home. And then furthermore, I think there's a lot that we could be doing to reduce our battery sizes, mainly by load controlling and automating loads. For instance, our thermostats, our hot water heaters. We can use simple algorithms that will measure voltage of our batteries and voltage of our panels. Some simple example of that is the Victron charge controller that we'll use on some of the larger charge controllers. They actually have internal relays, and you can program it to say our solar panels are at this voltage, our batteries are at this voltage. So they're full and we're producing power, let's close the relay and deliver some more power to our hot water heater. We can heat our hot water up to 200 degrees and then use a mixing thermostat, because it's no less efficient to heat with electric to heat the water to 200 degrees as it is to 90 degrees. You're still just adding kilowatts to essentially a heat battery. Same thing goes for our air conditioning. I think we can turn the temperature of the house down a few degrees if we have the power available. Solar is extremely cheap relative to what the battery cost is for an install. So I think I feel like we shouldn't just focus on battery storage. I think a big part of what I'm trying to get into is automation, and furthermore too, just stuff like opening the windows when it's cold outside. We can have window actuators that will automate all of that, and been doing some Arduino projects, some simple things like that. So I think that's a really simple way to reduce our battery needs. And so that's kind of a goal of mine too. With Nissan, with EVs that we mentioned earlier, we can now funnel some electricity into that. If your car gets 200 miles, you don't necessarily need 200 miles, like only deliver power to the car when the solar is available. So I think there's a ton of low-hanging fruit that I want to talk about also, and kind of stimulate some thought and some conversation on more things than just batteries as well. So I don't know if you guys have any questions for me, but I'm happy to, conversate about any of that. Further, I guess, if you guys can only reach out to me at my email or through my website, and I'm always interested to hear other people's thoughts and ideas.
So, somebody raised their hand. Kevin, go ahead.
Hi, I'm kind of coming at this in a new fashion, being only a Colorado resident since August. But I've poked at a couple of sustainability organizations here. I sent Ryan a couple of, I think would be interested parties in speaking to him through the chat. The first being the Now You Know father and son team, Zach and Jesse, because they interview people from all over on DIYers, on tech, on just CEOs,
And what research? I'm sorry, what was it you were mentioning?
Okay, if you look into the chat on this on this Zoomcast, you'll see the references.
Would you mind sharing that, Kevin, with everybody in the chat box when you get an opportunity?
Sure. So the first one is these guys. And as it shows back here, they have a lot of different fingers out from their original podcast, Tesla Time News, into various areas of sustainability. That's their main focus. Secondary, we moved from Wisconsin. In Wisconsin, there's the Midwest Renewable Energy Association in Custer, Wisconsin, and they are big on the education front across all disciplines, solar being a major thrust of theirs in both educating people to become installers as well as DIYers on many, many fronts. So I just want to bring out these two resources, and for Ken's request, I will post it to everyone in the chat, these two sources.
Yeah, absolutely.
So Ryan, in your setup, are you tied to a utility or electric utility?
I actually just acquired a new home, and I'm working out building permits, which is probably going to take more time than the actual installation. So once I tackle through that, I don't think it'll be too difficult because I don't plan on feeding power back onto the grid. I plan on slowly getting the entire house off grid. Right. What I want to focus on first is HVAC. They make 48 volt mini split systems. I would like to get one of those and start playing with that, especially if I can reduce the amount of need for my inverter, especially on big inductive loads. Something would be great to just keep the loads off your inverter on smaller homes, such as cabins or even RVs. We try to not use the inverter at all. But right now, I don't have any solar in my house. I have 900 watts on my RV, or sorry, on my trailer, which doesn't sound like a lot, but I weld on it. I run all my tools on it. It does fine. They're always charged. It's a slow start. I sometimes power a little window rattler, a little HVAC, a little window AC out of it, just because I have it available. But my goal is to build, let's see, 2.2. It'll probably be 4, 6, probably be around 18 kilowatt hours for the house. And I think that should be pretty sufficient, especially if you're using things like your water heater will be, only add heat to it when the sun is available, and stuff like that. I think I can maybe drastically reduce the need for large batteries. So, it's just.
Yeah, I think one of the we have we talk a little bit about know before you go solar, and it talks about the energy pyramid, right? So in a home, you want to make sure that you have all the energy efficiency things done first, right? Before you go with solar and battery and all this expensive stuff, right? So you can minimize your energy requirements.
Mm.
That way you don't need as many panels or as big a battery, whatever. But I think John pointed out the issue that we had a solar installer give us a presentation on the Sonnen battery, right? And that Sonnen battery comes in various sizes, but it's very expensive, right? In the small size, it's still about $15,000. And if you get it into the 10 kilowatt hour battery, then it's like it's $20,000, right? It's really nice from the standpoint that they've worked with the chemistry of the battery, with the iron. I forget the chemistry, but it doesn't go into thermal runaway, right? I mean, like a high energy lithium cell for a car would. And they have a lot of software in there that kind of manages the system. But like you were saying earlier, you can't put these in a cold climate, right? They need to be kind of environmentally contained, right? It needs to, for the battery to perform well, it needs to be 40 degrees or something like that. Do you know what the optimal is?
Above freezing. But the bonus of this is that you are able to discharge the battery well below freezing. You're not allowed to charge it. Okay. So we can add simple things such as heat tape, some kind of heating element inside of it, very low load. If it's an insulated box, it's the heating, keeping the batteries warm isn't too much of a concern. And another thing is you got to realize is that we talk about thermal runaway and stuff like that, but these batteries will not see near the amount of abuse that they will in a car application. I don't plan on discharging a lithium battery for 3 to 4 days maybe longer. Like my batteries rarely go all the way down. And in a car application, you might discharge it in a few hours, and then you might discharge it. It might get 2 charge cycles a day if you're going to work, charging at work, driving back. So the amount of abuse they'll see in a home application, I mean, you should be able to get 20, you should be able to get well over a dozen years with this kind of technology. People always ask me, how long are the batteries going to last in an off-grid application? I say, well, the Gen 2 batteries for Nissan last life, Gen 1 batteries for Nissan Leaf ended in 2005. So I have a lot of Gen 1 batteries. So those batteries are going to be 15 years old by the time they get to me, at least. So, and they're at 70% capacity, most of them. So it took, 15 years for in a car application, or maybe we'll say like 10 years in a car application to get to 70%. Now it's not applicable for a car, but if we're going to be treating them like in an off-grid situation, I mean, I would assume you're going to get 30 years out of a battery like this now, because I get maybe one full discharge a week, like rarely do I discharge my batteries fully. But the beauty is with the lithium is that you can leave them discharged for weeks and it doesn't damage them. You can drain them all the way down, and it doesn't damage them, like in the wintertime when I'm not getting as much sun. So you still get tons of benefits. But in these batteries, I mean, it doesn't matter if they're at 70% because we can size is kind of irrelevant in an off-grid application.
I think John had a question. You have your hand raised, John.
Yeah, I have a question, but a comment first with what Ryan just saying. I attended a presentation, the Denver EV Club a week or so ago about new battery technology for EVs, and they're with the changes or the advancements, they're talking now that you're going to move your batteries from your first EV into your second EV. The batteries are going to actually outlast the car, they're suspecting. So that's coming. But the question I had for Ryan is are there DIY systems for battery management? I was really intrigued by your comments on that. And I think that's a new frontier. Are there things we can do to begin to explore that area of energy management on our batteries?
Oh, so you're referring to the battery management systems that are on all lithium batteries. Most lithium batteries, you'll need some sort of an additional hardware piece. But yeah, there's all types and all sorts of battery management systems. I've had a lot of conversation with people with the difference of active management, active cell balance, and passive cell balance. How we can, on active cell balance, we can take power from our high cell and move it to our low cell, so it'll actually keep all the cells more balanced. And I talked to a battery testing facility in Arizona, and they said all that is for is it really just preserves the life of the battery. It gives it extra life, but it won't really give you much more capacity. So there's and it's an extra, it's all an economic game that we're playing, really. It's like, is it worth the extra $200 per battery to add active balance when the battery's already gonna get 15 years out of it? Are we trying to preserve it? But I don't know if you're referring to that system or if you're referring to what I mentioned earlier, is like in the Victron charge controller, you can offer load control and stuff like that.
Yeah, the load control, being able to push the pot once your batteries are charged, have it go to your water heater. I think that's brilliant.
That's one of the things I'm actually maybe most excited about. There's an Arduino. I'm not sure how familiar you guys are. It's a very simple microprocessor. It fits about the size of your palm. And what you can do with it is it will take about 6 analog inputs, which is a simple voltage of 0 to 5, which could be a temp sensor. It could be a voltage by a voltage divider. So if we have a 24-volt battery, we can divide that voltage. and measure the voltage of the battery. We could use it on a variety of different sensors. And then the Arduino has about 10 digital outputs, which is simply on or off. And we can use those digital outputs to control relays. And it's very basic. I've been programming in LabVIEW, which is a graphical programming language, and I've been building simple systems. I've also been using that same Arduino to build discharge curves on some of the batteries to kind of understand more of the how that battery, where that capacity is, and what voltage and what you can expect that battery to do at a voltage, certain voltage. Because you know, for lithium, it stays relatively flat and then dives off. So it's you'll be able to graph that trend with simple things like Arduinos. But yeah, I think there's a lot of room for that, and I'm really excited to explore that a little more.
Thank you.
But yeah, mainly hot water heater would be great. And then HVAC, and then furthermore, what would be nice is if we could make smart utilities or smart call it smart appliances. And what that could be is simple. And if you're running a 24-volt fridge, for instance, off your battery bank, you could have a simple volt sensor on there, and you could have two thermostats. Say it's a freezer or a fridge. Say it's a fridge. We'll do one thermostat at 42 degrees, and then we'll have one thermostat set to 34 degrees. So we have essentially a maximum and a minimum of where we want our space to be. So we can use a relay to simply turn the switch thermostats, and you know, thermostat's just going to be a open or closed switch. So we can essentially use that and measure, all right, how full of our batteries, and if our batteries are full, let's switch to thermostat number 2, which is preset. And now our fridge goes to, we'll say 36 degrees or 34 degrees, just slightly above freezing. So, you know, that would be great to experiment with that. And the goal isn't really necessarily to save energy, right? It's like, it would use more electricity that way, but the goal is to reduce our battery needs, because we can get solar panels. The price of solar panels are, you know, much cheaper, and I would say it's a very small fraction compared to the battery bank system that we're going to be using. So there's a lot of room in that. So it's all a matter of just kind of like,
In the house you're going to build, are you going to run DC voltage around the house then, or is that your plan?
No, on larger homes, I tend to just use because my inverter is going to be on all the time anyways, and it just seems not worth the extra cost. I would like to do my water heater to 48 volts and the HVAC to 48 volts, and then everything else just run on AC. Some of these inverters you can get pretty efficient. So it's really when it's a small, like a cabin, like a hunting cabin or something like that, then I'll start to run more DC loads. If there's a way that we can just turn the inverter off altogether and get away with just like lights and so on. So that's when it becomes a lot more beneficial.
On the water heater you're talking about, is it just a resistive water heater, or is it a heat pump? Or
yeah, I've explored some heat pump. Those are interesting for sure, but no, I haven't actually had my hands on one. But right now I'm just doing just resistive heating elements inside of it. And they have 48 volt heating elements, so it's very easy to just convert a water heater to DC. The trick then would be to replace the thermostat and then use a mixing thermostat. Well, you would essentially have your thermostat in the water heater set to just below boiling, and then you would use an outside mixing thermostat to then control the temperature of the water going to the house to say 90, whatever you want it to be. Like in a heat pump application, it would consume a lot more electricity, right? And as soon as that water starts to get, your heat pump is going to be more efficient at heating that water up to 90 degrees. But as soon as you start heating it up more and more, just like gas, you get less heat transfer. So it's going to become a lot less efficient with a heat pump. But if you're using resistive heating elements, you're going to add 3,000 watts to that 40 gallons of water, whether that water is set at 150 degrees or whether it's set to 190 degrees. You're just going to add 4,000 watts to it. It's not going to be any more or less efficient. So that's one of the problems with this I see with the heat pump. So there.
But Ryan, you showed me you have a DC refrigerator, right? You've been experimenting with that, DC refrigerators.
Yeah, I've recently learned how to braise, and that's gonna probably come in handy with HVAC systems. But yeah, I've been ordering DC pumps and brazing in DC pumps into AC fridges, evacuating the lines and so on. And what's really nice about that too is that if you have a fridge that fits in a space, we can convert it. So I've done about a half dozen of those or so on, but that could be something also that we're trying to tackle in. And then one other thing that we haven't mentioned too is that I would like to get more into gray water. Also, that's like another, but that could be a whole nother discussion really to go down that. But I think, Colorado and Utah, we're going to see huge, I think water is going to be a much bigger issue than electricity in the near future. So it's a lot of issues we could tackle, but only got so much time in a life.
When you talk about the gray water, are you talking about recycling it?
One of the goals would be to do recirculative showers. That would be really awesome. I would love to get into that. I have a little bit of resources on my website. It's more in just like the idea phase, and it's kind of just to spark interest in people. And if anyone wanted to like collaborate on that, another system would be to use it on plants, trees outside. Of course, you would have to use some very specific detergents and soaps, but in a recirculative shower, you can filter it back to a state that's clean enough to drink. You'd send it through a series of filters and then a UV light. And then another big bonus of that too is that you only have to keep the water up a few degrees. Your water that's going to be recirculated might only lose a few degrees, so you only have to make up whatever energy is lost. So I think there's a lot of win-win in that subject as well.
We lived in Austin, Texas for a long time, and out in the hill country, and we were on a septic system, and the septic systems are quite complex out there. It's like you have your whole little sewage system, right? I mean, compressed air pump. So there was 3 tanks, right? One kind of the introductory tank, and as that water cleaned, it would pour into a second tank, and then finally it would go into a third tank where it was chlorinated, and then from there it would go into a sprinkler system and be sprinkled on, not on your lawn that you use, but on some property that wasn't really used much, right? So as opposed to an underground piped system or something like that.
But why not on the lawn?
It probably has to do with the state laws with that. But you're right. Why not?
And even furthermore, why not on plants you'd eat?
Yep.
If you're using all natural detergents and soaps, phosphate free, I'm not worried about oil off my skin or dirt. I mean, especially if it's not going on the leaves or the fruits itself. I wouldn't have any problem. I think it'd be a great experiment and a great study to do that and start analyzing what's in the biology of the plants, or just the soil content. But water recycling, battery recycling, the list goes on. But
I had a
yeah,
question.
yes,
Just
Scott.
back to the water heater part. You know, a lot of times as you use it, water heaters are more efficient. But you had an interesting point there. Is you're, you know, now just capturing solar energy that you're not having to put into batteries. Have you done any looking? You know, because I was thinking about converting some of my water heaters to just the as you use it type, just because resistive heat isn't the best way to do things. But yeah, you brought up a really interesting point about just a way to store that. Any thought on those resistives? You know, I hadn't done it yet, so.
Well,
And the
I
instant
think
on ones.
I think it was like 16 kilowatt hours to heat 40 gallons of water from 90 degrees to 200 degrees. It takes about 16 kilowatt hours of electricity. So at 350 a kilowatt hours, that's a $5,600 battery that you have in your hot water tank. And if you have a 3,000, I mean, there's got to be a way to do a combination of the two also. Like you could do a heat pump, but I mean, again, it's this economic game that we have to play. It doesn't really make sense because if your hot water never goes below 120, you're using a mixing thermostat. The heat pump doesn't really become applicable. And a real off-grid application, you could do even like a backup on-demand water heater of some sort.
That's what I was talking about, the on-demand, like they use in Europe and everything.
Yeah.
I just wasn't using the right term.
Do they have a heat pump on demand? Is that what we're referring to?
No, I was just asking, my initial thought was use the on-demand just because that's a little bit more efficient than using resistive heat in a standard water heater. But you've just brought up a new wrinkle to it that maybe, even though it's more efficient, you know, if you're not buying batteries, maybe it actually isn't more efficient. So I just kind of like that idea. And
again, the goal isn't to save electricity here.
Correct, as you said.
It's to save battery capacity because that's where the real money is, and that's really where the whole environmental issue is. Because if we can get solar for 50 cents a watt, if you can get polycrystalline solar is sometimes as low as 30 cents a watt. It's just it makes economic sense to just forego some efficiencies if we can store that energy in other ways. So there's a lot of low hanging fruit. I think Ken brought up a good point too, where you said that if before you even think about solar, like switch your lights to LED lights, get an efficient fridge, get an efficient washer dryer, things like that. It makes a lot of sense before you're going to go get solar. Because again, it's this economic game that we play. That's, I think, the big reason we have to make. A lot of people want to go off grid. They want to get solar because it's good for the environment. But really what it boils down to for most people is that doesn't make sense economically.
The only thing, back to that state law that hopefully would go through about that, the percentage, that 120% that you can have. I actually made the mistake. I went very energy efficient initially, and Colorado Springs would only allow me to put on like a 3,000 watt, or actually it was about a 2,000 watt system basically.
Yeah. So they're penalizing you for being efficient.
Right. So I ended up just running electric heat one winter just to boost my thing up.
Yeah, that's the world we live in.
It was absolutely horrible. I mean, it just made me sick to do it, but
it's like use it or lose it, with the water.
Right. So. And it was the same thing. I didn't have an electric car yet. Now I have one. Now it wouldn't have been an issue, but that is one issue about, if you think about doing it, you may need to have that usage data, because they look at that last year, kind of a shame. Or hopefully the bill will go through and we won't have that issue.
Yeah, I don't understand why they're basing it on your own usage, they should base it on the transformer or the wires that are going in your house, so the capacity that they're able to deliver. That's what I would think they'd want to base it on. Say they can deliver a maximum, I don't know, I'm just going to pick an arbitrary number of 6,000 watts. That's like you have a 200 amp breaker. It's probably a lot more than that, but they should cap it at that. You know what I mean? Like let you put as much solar on as you want, as long as you're not going to overload their lines. I think that would be my biggest concern as a utility. And I'm on the utility side in a lot of ways too. It's like they have a ton of overhead. They got a lot of liability, a lot of issues. So, we got to also look at it from their point of view as well, in some circumstances.
Yeah, the municipal utilities and the co-op utilities, they're kind of member owned. They look out for it's a nonprofit model basically, right? They're just really looking out for the customer, right? So it's kind of like the credit union model. But there's also investor owned utilities, right?
Yeah.
And the way they make their money is by making big investments, right? They're regulated monopolies, so they almost have a guaranteed they almost have a guaranteed 10% return. It's not a gigantic return, but it's very stable. It's very low risk. Okay.
Yeah.
Now we need, this electrical system needs to be reliable. We saw what happened with Texas. If you don't, if reliability is not important to you, you lose that electricity and you become a third world country, right? Everything breaks because everything requires electricity. Anyway, so I think every state kind of has their own public utility commission for their distribution systems. Of course, we have FERC for the transmission stuff, which is federal. It's the IOU model is still a for-profit model, and they're looking out for themselves. So, John, you had another question?
Sorry. Yep. Yeah, I put it in the chat, but with this latest conversation, another future topic might be just what some of our members have done to try to, capture energy, solar energy during the day to be able to use it later at night. I mean, I've explained that to Ryan. I've got a small Goal Zero that I charge during the day, and then I run my lights in the living room off of it at night. And which has helped me to just turn the corner to be able to, because at the end of my year, I was always having to pay a little bit for electricity, but now that has helped to turn the corner on that. So it helps to not have to add more solar capacity. So I'm sure there's lots of other ideas that we might be able to share in that regard.
Yeah, because what are your loads really at night? I mean, lighting, if you can cool the house down while you still have sun with some simple automation, I feel like we could drastically cut our needs for at night, not having to run the water heater at night, not having to run the HVAC at night, maybe not even having to run the fridge at night. If we can use some simple algorithms to control all that. I did have a question too about the utility. Are they giving you any rates, peak rates? Are they penalizing you for using electricity around, in the peak times at all?
Not yet.
Yeah, I mean, with Black Hills, no. I mean, not yet. However, they're introducing in Black Hills, they're introducing these time of day rates. I think other utilities around Colorado are starting to do that. I think Excel is starting to do that, and Excel is the big one, right? It's the Denver metropolitan area. It's more than that, but
I personally think that's.
So we don't have these. So we don't have this time of day rate yet for most of us, but it's going to happen because that's one of the ways you manage the load of the system, right?
Yeah,
so,
I think it's a great idea. Actually, I would strongly encourage utilities to do that. I think anything to encourage people to use more electricity at shoulder time versus at peak. And if we can, if there was even a website or anything, that would give consumers feedback on how much demand there is. I think Google, the Nest, I think Google came out and said, if we can control everyone's thermostat by like 3 degrees, the amount of electricity they would save is astronomical. But obviously nobody wants their thermostat regulated by Google. But I mean, if it did save.
Yeah, but you can get these smart thermostats and put your own program into them, right? So so you can do that. I mean, we're in the United States, we're all about independence. So, John, did you still have a question, or are you done? I see your hand.
Nope. Thank you. Yep. Sorry.
That's okay.
Ryan's been talking to my wife on when to not running the thermostat, not letting the machine run the thermostat. He says, I'll get up and I'll fix it when I want it. But we're not going to do it. We got a smart thermostat when we got our solar. We never used it to its capacity.
You said you've never used it, or you have?
We've never used it the way it's supposed to be. We go over and move it up and down and that kind of stuff. I don't know. But my gas is my biggest expense. I can figure out how to power up natural gas. I'd have to do it. I've got enough solar on the roof. I never believe I did. I have 15 panels and I think I got 475 kilowatts. But 475 kilowatts. But I always end up in the black on my electric bill. It's when they stick in the gas bill on me. I'm with Excel, and they've got both as one entity. But they also charge me 0.04 cents a kilowatt at night, 9 o'clock at night until 9 o'clock.
Yeah.
I'm having a little hard time understanding you, Bob, because your microphone's kind of in and out. So,
how about if I get closer?
It might help.
If I could kill the 300 watt in-weight bulb, I'd have it really whipped. That stays on all the time. Other than that, I got nothing.
Yeah.
I know.
One second here. I think there's a lot of benefits of that. I think you could simply do a timer system, and then, like I mentioned with the fridge, you could have 2 thermostats, and you could set each thermostat to be the minimum you want your house to be, and you could set it to be the maximum. I don't want my house to be a degree over 80 degrees. Then if a house does get to 80 degrees, it doesn't care what the rate is of the energy of the electric is. We're going to turn the AC on. But then you could also have a minimum value of, say, 65, which is freezing. But we could say, hey, if the sun is out and our batteries are full, let's turn the temperature of the house down to 65. And then our AC doesn't have to maybe kick on till 4 a.m., when after the sun goes down. It's just some simple, it doesn't even really, that requires a simple voltmeter, a little volt sensor. You can get those on eBay for a few bucks, and 2 thermostats, and you got yourself a smart HVAC.
I don't know if this is applicable, but this is something I've been reading real currently, so I don't really know a lot about it. But there's this heat engine, and this thing is really designed to be a utility scale system. So they're talking about they're talking about using a heat pump and sending the heat to a eutectic salt that would hold that heat, and sending and also having a cool water liquid tank, right? So you separate the heat and the cold, and you store that energy thermally, and then when you need it, then you convert it. You run your heat pump in the opposite direction to convert it back to electricity. So
Yeah, I mean, there's a lot of potential in all of that, really. There's more ways than batteries to store energy. And heat it takes a tremendous amount of electricity to create heat and to remove it. So I think there's a lot of room for improvement and that sort of thing. I don't know what exactly are the pie. If we looked at a pie chart on all the energy usages of our house, I would be willing to bet that, water and our cooling is top of the list. I mean, lighting with modern day LED lights is pretty minimum. Even modern day televisions, the LED televisions are pretty efficient. You got you might have some ventilation going in the house. But really, to me, it's your heat pumps, your air conditioning, your refrigeration. All of those things are what really drives up the electric bill, which all can be timed, and all of those loads can revolve around how much electricity is available from renewables.
I know one of the things we do, that's, Pueblo is kind of a warm, in the summer, it gets hot, right?
Yeah.
It's in the 90s, maybe even in the hundreds, right? But in the evenings, we're kind of a semi-arid climate. It cools down. So typically, gets about 60, in May, it's in the 50s.
Yeah.
Highs in the 80s. But I use an attic fan, a quiet, cool fan.
Yeah.
So I pump in the cool air at night to cool down the house, to get the thermal mass of the house down. And then when the temperature outside gets above what is inside, I'll close all the windows and use that energy to kind of push me through the day. Now we do need air conditioning here, but my AC, I really don't need it until about 5 o'clock at night, 4 or 5. Depending on how hot it is that day. If it's a 100-degree day, it might turn on sooner. But because we have no humidity in the air, that makes it work here. So
same as in Moab, it'll get down to 75, 60 degrees at night, and it's 90 degrees in the day. I had that happen. I had kind of an epiphany when I was at my folks' house. They live in Michigan, and it's 65 degrees outside. It's 90 degrees inside. They got the AC running. A lot of people in this country just don't want to turn the AC off to open windows when you could open windows and get the top cooled in no time. But that Arduino I mentioned, you could do some simple programming and develop a smart, so to speak, home where it would open windows for you, turn on ventilation for you, turn on and off the AC. Some simple things like that, I think it should save a tremendous amount of energy.
In the humid climates, you kind of have to manage that, inside the house, you kind of have to manage that relative humidity too, right? You don't want to get it too high.
Yeah.
I think you want to keep it, also it's maybe not that energy efficient to do that, right? I mean, when your house starts to get above, 50% relative humidity, it starts to feel different, right? I mean,
it's one reason I don't really like swamp coolers. I've been in some buildings and they have the swamp cooler on, and not to mention that swamp coolers are going to be, we're going to be hurting on water, and it doesn't make any sense to be putting it in the air. And I personally don't really enjoy being in a room, even if it's 75 degrees, if it's at 100% humidity. So I've definitely been in a few buildings like gas stations and so on. You're like, oh God, it's cool in here, but it's like not quite comfortable. You mentioned thermal mass a little bit too. And I met a guy in Quartzsite who had an off-grid home, and he was raving about it. He's like, that is what you want. You want thermal mass in the house. You do not want to insulate the concrete walls. You want that heat, and you want that cool air to go into the surrounding ground. One of the things I would like to do is put a wood stove in my house. That'll definitely help me get off grid. But I want to funnel hot air down into the basement and get the basement really warm, so that, you know, when the wood is out in the morning, or, you know, it's kind of like, so to speak, your batteries are out in the morning or low, that it will help regulate the temperature of the house a little bit. Mm.
Yeah,
Uh,
I don't know. I mean, there are folks better than me to talk about passive, solar homes, where the way you design them. But we have a individual who was experimental like you. So he was in the energy field. Steve Andrews is the gentleman's name, and he built a passive home. And he talks about insulating the foundation, so it doesn't so it doesn't talk to the earth, and basically you build a really tight building. You design it so it takes in the winter sun but not the summer sun,
mhm.
and then you use that thermal mass of the foundation to kind of regulate the temperature. And he said because of that, he doesn't get a lot of temperature variation, and it's always cool. It's always comfortable. So you don't have the big fluctuations in temperature. You have to worry about indoor air quality because it's so tight.
Yeah.
But so you run a little, low noise ventilation fan, right, to kind of keep the air quality good. So
I would like to link you guys up with my cousin. I was briefly, for a few years, I was helping him design some homes, framing for, he does LEED Gold, a lot of LEED certified homes. And he's based in West Michigan. His company is called Abueva Builders. If there's any way to share resources at the end of this, I'd love to share his name. I've built a few homes with him, and he does his homes are so tight that they'll do for the HVAC, they actually will bring in fresh air, and then they'll heat it. It has a heat exchanger, and it will heat the incoming air with the outgoing air. So it's an efficient way to get fresh air into the house without sacrificing too much losses of energy. He's got quite a bit of foam insulation around the concrete, which is an interesting thing. To me, I want the ground to absorb heat, and I want it to radiate heat, and I want it to radiate the cool temps as well. So I just talked to a guy. I think that's a little bit different for I think the circumstances if you're off grid, relying on energy storage essentially, versus if you have our grid tied. Again, it might be more energy efficient to insulate your home, insulate your foundation walls. But if you were having solar and we got a surplus of electricity and nowhere to put it, the surrounding earth is not a bad place either.
you might want to share that information in the chat, Brian, if you can.
Yeah. All right.
That way we can record it, right? Okay. Well, this was an interesting discussion. Any other questions?
There was some talk about, turning things on and off. And there was a local company, Emporia Energy, I think up in Littleton, Colorado, that makes these little current clamps that go around all your lines basically. And so It really helped me figure out exactly where my power was going. And, then, you need to know where it's going to be able to do anything about it basically. And so I found my dish antenna was using a whole bunch, had them go swap it out with something else. The refrigerator or, no, it was a garage door. It was using some, not a whole bunch, but I don't use it after 10 o'clock at night. And so I put those controllers on there. So with some of those controllers that you can get, little Wi-Fi ones that go around, it was quite easy to have things turn themselves on and off at different times. And it was amazing what you could reduce the load by just turning things off when you weren't actually using them. And there were a lot of things that could get turned off totally And I really like your idea on the thermostats because, yeah, I of course didn't turn off the fridge, but that idea of 2 thermostats might be a,
Yeah.
just a way
Nobody
to
wants
get
to
just a little bit better.
nobody wants to turn their fridge off, you know.
Yeah. And I was a little bit worried about that.
Oops. Now all my food's gone. It's like forgot about it. But I think there is some simple automation that we can implement, and I think it's very in reach. I mean, we have the technology. It's all there. I mean, we've had it forever. It's just a matter of putting it to use.
Yeah, and this
Yeah,
stuff was
Ames.
literally just go and buy it from Amazon. These little, I do things with Adrenos and Raspberry Pis also, but
Yeah,
it's not accessible to just everybody. But anyone could put a timer on their garage door and just have it turn off at midnight, turn on at 6 in the morning. And
yeah.
for the one time when you actually have to leave the house, you push the little button and turn it on or something. So there's a lot of little things like that that anyone can do, and they don't need to be a coder or anything. So
We've thought about doing that with freezers too. Like if you have a chest freezer, you could put a simple timer on it and set the temperature of your thermostat to well below freezing, and then just have it, at night, it's not going your food's not going to all thaw out over the course of 10 hours. And then in the morning when the sun comes up, you know, we just surround it via the time. It, like you said, it's just a super simple. I mean, again, this is if you have solar, because it's going to consume more. It might consume more electricity to do that, but if we have a surplus of solar, like it'd be a great way to make use of it.
There's a now this is not the most economical device, but it's pretty neat. It's called Sense that you put in your panel. It has inductive collars, so it kind of monitors the power, but it can recognize different appliances. I think the future is going to bring this, that the appliance is going to tell the is going to transmit a signal saying, hey, I'm the refrigerator, hey, I'm your toaster, hey, I'm your blender, whatever. But the Sense thing, kind of has a database to kind of understand what it's looking at. So it'll give you little bubble diagrams real time on where your power is going. Now it does cost, I think it costs around $300. And they make a Sense system also for your solar production. So there's 2 sets of CT collars, one for there's 4 collars, in other words, for a 240 volt system, one for each phase of the load, and a couple for the phases of the production solar.
Yeah. And I think data, like Scott said, just having that data is extremely valuable. Just knowing where your power is going, knowing, it's super helpful even to know what to expect in your battery. If you ever do go the battery route, and your batteries are at 20 volts, like what does that mean? Like, because it's not a flat linear curve. It's if the battery voltage is at halfway between full and empty, you don't necessarily have 50% capacity left. So just having all of that data available for you is extremely valuable, in my opinion. Ames Dynamics is a company. They make, I'll even type it in here. That is a company that produces sensors. I've been using them. I think that's the website. Anyways, you can do simple amp clamps, like Scott said, and you can do a variety of them, and they'll just give us a simple voltage back of 0 to 5 volts based on the amperage, and we can use that data, to even to drive other loads and so on and so forth. So there's a lot of cool things out there that you can do with simple Arduino, and eventually maybe I could build some kind of smart thermostat system for off-grid homes. I would like to get into more automation and so on. I think that's a lot of low-hanging fruit, but in the meantime, I'm going to be focusing on salvaging more different types of lithium batteries and all sorts, just of energy storage methods, really. And then maybe move into water and so on and so forth.
Okay, well, Ryan, thank you so much.
Yeah, my pleasure. Please reach out. My website, I don't know if you guys, you can reach out. I'll put my email to you. But reach out if you have an epiphany and you say, oh, wait, I know a guy that can, you know, maybe that off-grid, that water, you know, there's a filter out there that, you know, will last forever. I don't know. I'm always interested.
Ken, thanks again. I just want to thank Ryan again, and thanks for what you're doing. I like the idea, and I hope we'll see more of that over time as we get more EVs on the road, and be able to harness that battery storage in our homes. So thank you.
Yeah, and I'm not really, I wish I had like a blog on my website. I'd love to, I meet people like you guys all the time that have all this interest, and I'd love for them to stay in touch and see what kind of progress I have. So I'm not really a social media type guy, but I did create like an Instagram for my company. I occasionally post what I'm into, what I've been building, what I've been working on that. I would maybe get on to, I have a friend that has a similar company. He does more retail. He does, I'll put his website on here too. He's trying to do more DIY things. So if you wanted to do, build a system yourself, he would include all the charge controllers, kits and everything like that. So he'd let him do the shopping around, let him find out what would work well. And he's going to be putting together some small off-grid kits, more retail. I think he's kind of trying to aim for like a company kind of like Southern Arizona Wind and Sun. I'm not sure if you're familiar with that, but they have a huge retail on all things off grid. EV West is a great website. That is for DIY automotive. They have a lot of motor options and conversion options for all sorts of EVs. I personally would love to build like an electric UTV. Being in Moab, those UTVs are everywhere, and I think that'd be a great project. So Homestead Hive. So those are. Is this chat going to be available after we close this, or?
Yeah, I could send it back to you. Sure.
Oh, the whole like chat log.
Yeah, if anybody's interested, in the chat, let me know. I'll put my email here.
Yeah, I mean, I'd be interested for sure.
I've been putting it on our minutes, all of the places that you've been recommending right now.
Okay. Yeah.
Okay.
I think if I have anything else, really. Yeah, just trying to. I'm also doing. I guess I could show you. John mentioned my little mobile shop, but I also just moved into a garage actually. So, been doing right now. We got some custom frames. This is a solar racking system that's going into a system in Paradox. It'll be 1400 watts ground mount. And then back here those are batteries out of a grid storage that I've repurposed. And then here I just have actually what's my table is just some simple. I've got a bunch of I have some salvage right now. These are polycrystallines out of an old farm that they upgraded. So there's always ways to get affordable solar panels as well these days. And then this is an example of a 2 kilowatt battery right here. I don't know if you can see it, but that just for a size reference is about 2 kilowatts. These are Nissan Leaf batteries right here, out of a Nissan. I have this little project this was going to be an ammo can that was going to be like a waterproof battery for like UGS or the forest department. Kind of got overwhelmed on that project, but there's always something happening over here. So yeah, send me some ideas, whatever you guys want, and I'm always free to chat.
Okay, well, thank you.
Thanks, Ken. Thank all of you guys, and God bless you. And I'll be available if you guys want to collab or anything, or pick my brain for sure.
Okay, thanks, Ryan.
All right, have a good day.
Yeah, have a nice evening, everyone. Thank you so much.
Appreciate it. Bye.